Good morning, everyone. My name is Katherine. I'm from Impera Software. Thanks for coming. My talk today will be on porting software to RISC-V using Impera's virtual prototype. Now, before I even go on, the reason for us to pick this topic is that RISC-V has been around for 10 years, but then there's not a lot of hardware around. How do you get even started with software porting? Use a virtual prototype. A brief introduction of Imperas. No one tapes out a SoC without simulation. At Imperas, we believe no one should release software without simulation either. Imperas develop simulators, models, tools to help embedded software developers and also designers, processor designers, SoC designers. We're based in UK. We've been established for over 12 years. We're self-funded, and we have plenty of customers worldwide. Now, before I get started into software porting, at RISC-V Summit this year, we were very excited to launch our Imperas DV methodology solution package. We've been working with many customers over the last 5 years, and they've helped the RISC-V processor developers to validate a lot of complex processors. So based on that experience, we put together a solutions package for RISC-V processor design verification. So the idea is a step and compare, lockstep comparison. The idea is to compare your RTL, design under test, to golden reference model. It's easy to say that, but doing that, especially for complex processor, is really tough. So let me look at this diagram a little bit in depth. So on the left-hand side is your design under test. On your right-hand side is the Imperas reference model. And then there will be tests coming out from test generator, from constrained random tests, or your test suites. Now, you want to compare them, but it gets complicated when there's interrupts, debug mode, multi-hearts. And from our experience, this is the whole solution we put together. So in the middle, there's the test bench, which controls and helps to synchronize the events from both the DUT to the reference model. So this whole solution makes it a lot easier for our customers to bring up and set up this kind of deviant environment for even very complex processors. We provide, of course, the reference model, a set of APIs, the test bench. The test bench can be System Verilog, C or C++, and also capability to do functional coverage, instruction coverage, and so on. So please come to our booth to learn more about this solution. As you can see from my previous slide, we have the reference model. Now, that's the key. It's the key to have a reference model that's up to date, accurate, and fast. And with RISC-V, it's so configurable. It gets pretty complicated. We've been doing processor modeling for a long time. So Imperas applied our expertise to modeling RISC-V. We provide an envelope model, as you can see. We support all the rectified and even near rectified extensions. Our reference model has been used for compliance, software bring-up, verification, and test development. Our model is provided under Apache 2.0 open source license, which means that you can take that and modify it, and if you don't want to publish it to the public, you don't have to. It's been used as the golden reference model by quite a few customers, and I have the names up there on the screen. Now, a little bit more on the base model. The base model provides the extensions in full, And you can even go back and choose back versions. With RISC-V, the fun is to be able to extend it. Everyone gets an architectural license, and now you can put your secret sauce into the extension. We have architected a methodology to make it very easy for our customers to extend the RISC-V model that they design. So the way we do it is there's the base model, and on the right-hand side you can see in orange that is the extensible section that our customers put in. And it's a side file, so it doesn't affect the base model. And we provide a lot of templates, examples, documentations to make it really easy to add that kind of extensions to RISC-V. All right, let me try to bring all these together. So what is a virtual prototype? A virtual prototype is a set of instruction-accurate models that reflect the hardware. That is the target hardware. It runs unmodified production binaries. And it could be from a very simple SoC to be as complex as a full board. On the right-hand side, I show an example. It's actually a real project that we have done. It's a heterogeneous platform. So you can see there's a RISC-V processor, and then it got combined with a quad-core AP. And the upper side core, it boots up free RTOS, and the bottom AP boots Linux. And we provide a set of peripherals that lets customers easily put that together as if they're doing it in hardware. Imperas is very fast. Our customers typically experience 200 to 500 MIPS, and we boot Linux in less than 10 seconds. Another key differentiation is that we can leverage the host computer resource. So in our demo in a bit, you can see that we leverage the resource of the workstation, mouse, display, and connectivity. Now, porting software is not that easy. To do that, we provide a set of tools. Now, a customer can use our tools, and they can also use their tools of choice. Now, let me go through this diagram a little bit. So on the dark blue block, that is the virtual prototype. It consists of our very fast processor models, the peripherals, memory bus, wired together just as is in hardware. So that's the virtual prototype. That sits on top of our simulation engine, and our simulation engine connects to our tools through API as well. So we have two high-end specialized tool set. One is a platform-centric debugger. We call it multiprocessor debugger. And even for customers that have heterogeneous platform, that provides a unified debug environment for them to look at the entire system. The second set of tools is software verification, analysis, and profiling tools. We have dozens of tracing capabilities. It provides memory coverage, code coverage, and so on. And then your application software, the test bench, will connect to this whole system, this whole environment. So we differentiate by having very fast processor models, very accurate simulation engines, really scalable APIs, and also high-end tools. Other than software development, the next step is test. A lot of our customers use us for CI/CD, continuous integration, continuous test. Compared to hardware, the virtual prototype provides a lot of advantages, such as controllability, fault injection, full visibility, and so on. All right, so our demo today is the Quake game. So if you know the Quake, it was produced by ID Games from a while ago. It's retro. And we ported that from x86. I was told that it was running on 286 to RISC-V. So the demo is that the game runs on our virtual prototype. And you would experience it as if you were playing maybe even better than on the original hardware. We leverage the workstation resources such as mouse, keyboard, display. And not only it runs on RISC-V, it also runs on ARM and open source processor OR1K. You can play it just like in real world. Does that bring back good, fond memories? All right. So please come by our booth. It's over there to play the game yourself. And you can observe the performance of our simulator. On the right-hand side, we show a screenshot of the log file that we captured from the simulator run. And you can see that through the system time of about 5 seconds, we have run 119 billion of instructions, even with the sound effects. Please come by, don't be shy. We were begging people to show us how good they are with Quake. So in conclusion, Imperas, we provide tools, very fast simulator, over 300 processor model in our library. And at RISC-V, this year we launched Imperas DV. The benefits of using a virtual prototype is your schedule shift left through the capability of doing better software development and test. So thank you for being here. The disclaimer is no monsters were harmed in this simulation. And as a holiday gift to the world, this is December, so it's a holiday season gift. We have made that Quake game available on ovpsworld.com. Oh, .org, sorry. That is run by Imperas. That's where we provide evaluations and downloads. So please come there and download the Quake game. This is for the young and the young at hearts. And also come by our booth to play the game yourself. Thank you very much. That's the end of my presentation.